What makes non-Newtonian fluids viscoelastic? Imagine a liquid that can act like a solid one moment and then flow like a liquid the next. That's the fascinating world of non-Newtonian fluids with viscoelastic properties. These fluids are not your typical liquids because they respond to stress in a very special way. And like water, which flows smoothly no matter how you stir it, these fluids have a dual personality. They can resist sudden forces like a solid but also stretch and flow when pushed slowly. This strange behavior is what makes them so intriguing in science and even in everyday life. At the heart of this behavior are tiny structures inside the fluid, often made of long polymer chains or complex molecular networks. When you apply force, these structures stretch and deform elastically, meaning they store energy like a stretched rubber band. But at the same time, the fluid's overall structure allows it to flow and dissipate energy, just like a viscous liquid. This combination makes the fluid respond differently depending on how quickly or slowly you apply stress. If you hit it sharply, it resists like a solid. If you push gently, it flows like a liquid. This dual response is what makes it viscoelastic. Scientists use models to explain this behavior, like the Maxwell model, which combines a spring and a dashpot in series, or the Kelvin-Voigt model, which puts them in parallel. These models help describe how the stress in the fluid depends on both how much it's deformed and how fast that deformation happens. They show that the fluid's microstructure temporarily stores elastic energy, then releases it, which is why it can bounce back or slowly change shape over time. Think about silly putty, a common example. When you quickly hit it against a surface, it bounces back like a rubber ball. But if you leave it on a table, it slowly flattens and flows over hours. That's because of its viscoelastic nature. Other examples include certain lubricants, whipped cream, and polymer solutions. They all share this ability to behave like a solid under quick stress and like a liquid under slow, sustained force. This behavior is what makes non-Newtonian fluids so bizarre and interesting. Their internal structure allows them to store elastic energy temporarily, then flow or relax depending on how long or how hard you push. It's like they have a memory of the stress they've experienced, which influences how they respond. That's why they can bounce, stretch, and flow in such unpredictable ways. It's a perfect example of how physics can blend the properties of solids and liquids into one fascinating package.